So how many of you guys have written APIs in Ruby or Rails or Node, whatever it may be? Awesome. So the majority of you guys have. Now, if one of you guys can sort of speak up here, why did you end up building an API rather than just doing like a view rendering? Anyone?
You can do it because you want to aggregate different APIs. You want to all like concentrate them in one API.
Awesome. Anyone else?
Support different types of clients.
Yep.
Yes. But if you develop an API first, you wait for client to client. You don't write a view with the right API. And then support it.
Absolutely. Yeah, all those are really solid reasons. Some I listed down were, read about it in Hacker News. That's the most important reason. The second reason is you might have iOS or Android clients, a mobile app, whatever it may be. Maybe customers want access to some of your data, right? Maybe they want to do something with it and aggregate it, and you need to open it up to them, right? You're not just going to give them credentials to your database. He wouldn't like that. Okay. Well, we can talk after this. So multiple front ends, right? Potentially not browser-based. I mean, the company like maybe Netflix, they have tons of different front ends. The list goes on. Internal communication amongst your services, whatever it may be. But the idea is someone or something wants to consume our data. And we want to be able to give it to them in a format that's easy to access and that they can make use of whatever that is. So how many of you have made APIs in Rails in particular? All right, so a good number of you. I made a little, so there's basically Rails has supported APIs out of the box since Rails 5. There's API-only mode, which essentially just thins down the middleware stack, so it doesn't include a lot of the view rendering things. They added has secure token, right? There's been some support for making APIs in Rails. There's a default serialization built in with JBuilder. So there's been some strides made in that. But overall, like the way I've sort of seen the progression of APIs in Rails has gone a little something like this. First, we start with the active model serializers. This is somewhat more modern. Right? You define a serializer with your attributes and any relationships that you have, and you use that. Whoops. The other way is the JBuilder method, right? Where you sort of, JBuilder kind of gives you a view for your JSON in a sense. I kind of think about it almost like ERB or HAML, but for JSON, where you have this .jbuilder file, and when you render this, it's supposed to, the whole context of that file ends up being the JSON. And then finally, probably the best method for creating an API in Rails is just to do this. Just kidding, you don't want to do that at all. There's a lot of terrible things about doing this. Firstly, it probably won't render once you have more than a couple thousand posts. Second of all, you don't get any control over how you're serializing things, so don't do that. So when I'm building an API, I think the most important question I can ask myself is, how do clients consume my API? Like, what is their experience when consuming it, right? A lot of times on the back end, it's very easy to just get caught in the mindset of, this is how I might use it, right? Or you design your API like in more back end terms as opposed to client terms. So examples of this would be only exposing certain REST endpoints and generally making it hard to navigate. At the end of the day, every client has different needs. If you have an iOS app and then you have a web dashboard, right? The way that they communicate with your API, the resources that they need for their app can be very different depending on the features of that app, right? And this will also be very different for anyone consuming your data on the back end, right? They may have different needs. So it's hard to predict what the needs are of a client. So what do we send for an API response, right? Like, we don't necessarily know what it is that our clients are going to need. We don't have this knowledge up front, right? We already know that there's all these different needs for API consumers. Like, what do we send them? So traditionally with REST, this is what I see happening often. You end up just sending everything, right? And I'll pick on GitHub a little bit here, but they've talked about this publicly, and it's essentially what ends up happening is you just give a dump of pretty much everything that a client may need, right? And most of the time, you might only need 1 or 2 fields from this whole response, right? But in order to serve the needs of the majority of the customers, they just dump everything. So I will actually say that that is, with REST, that's actually good API design, right? Because at the end of the day, the clients end up making less requests and they get what they want the majority of the time. So it's easier for them to use your API. So that method is better than having a minimal set of fields and exposing, like, thousands of endpoints, right? So I will say that is good design for REST, but there are some pros and cons here. The pros would be, like I just mentioned, clients are happier because they have to make less requests generally. So possibly better for back-end performance because, once again, less requests. But this is also goes both ways because if you end up dumping a lot of data, like for example with issues, they also may dump comments with those issues. You end up doing a database join, so you end up doing a lot of work, so it might be offset, but it's potentially a pro. And the cons on this are, it's a backwards compatibility nightmare. Once you start adding these fields to the response, you can't take them away at any point in time, right? You're going to have clients that rely on that field. So you can't one day say, hey, you know what, I want to clean this response up. Like, this thing doesn't seem very important. Let's delete that. It'll make maintenance a lot easier. You can't do that. You have to support the whole thing, especially if you have a public API. This is not so much true if it's an internal tool, but for any public API, it's a compatibility nightmare. And sort of similar to that note, you don't have insights into the resource usage. And what I mean by that is when you just dump everything, you don't actually know what your clients are using from your API, right? It could be that half of those fields no one ever uses. You would just never know. So you lose any insight into the granularity of what's in that result. So that's a downside. And the reason it's such a big downside, I'll go over this a bit more, but the reason it's such a big downside is it becomes hard to sort of focus your attention on what's important in the API, right? So it makes prioritization harder for features in the API, et cetera. And at the end of the day, you still can't guarantee that a client gets everything they need in one request, right? Like, I've used the GitHub API extensively. I think the REST API is great, but I will say that I end up making multiple requests a lot of the time to get what I want. So even when I get a large dump like that, it's usually not all that I'll need. So overall, I would say, theme of this is we have made more problems for ourselves while still falling short and meeting our consumers' needs, right? We tried to fix the problem, but we ended up kind of fixing some things, but we also made a whole slew of new problems for ourselves. So this is kind of where GraphQL comes into the equation here and the problem that it's trying to solve. And I would sum it up as this. Give clients exactly what they ask for and nothing more. So let the client describe what it is that they need and send that back to them, right? As opposed to trying to guess exactly what it is they might need and just send it all. So a little example of how this might look, and this is from the GitHub GraphQL v4 library. You can see you choose your resource, the root resource that you want. We're going to say we want the Rails repo. we want the ID of it for some reason, and then we want just all the issues, or just the first issue, and we want avatar and the login, right? So we've chosen exactly what we want. We don't need everything else that comes with it, right? So they can just send back exactly what it is that we've requested, which is what it does. So yeah, I mean, a lot of people, and I think this is actually the biggest point of criticism I see with GraphQL in general is, just going back, they see something like this and say, hey, that looks cool, right? But how do I actually implement that? This seems like a foreign language, right? Do I have to build, do I have to build a parser, a lexer? Do I have to, traverse this syntax tree and do crazy stuff to make it work? And the answer is no, you don't. These days, pretty much every language out there has some sort of client library to make this stuff relatively straightforward. It will do all the heavy lifting for you. In Ruby, this is the GraphQL Ruby gem. It's pretty much what everyone uses. It's what GitHub uses, Shopify, and anyone who's doing a Ruby GraphQL API to any extent is probably using this. And what you do is you sort of define your types, and then you define resolvers. And I'll go into that a little bit. So the first thing that's important when building an API like this is defining your types, right? Types describe like the shape of your data. So up front, you'll say, hey, this thing is called a post, right? And it's a blog post specifically, and it has these fields. It has an ID field, right, of the type ID. It has a title field of type string, and it has a body field of type string. So up front, it's typed out, right? It's type safe to a degree, and it allows you to really define like what it is that you'll be releasing in your API, right? So people can actually look at this documentation and say, hey, I know exactly what I can get from this API. And then the other core thing besides types are resolvers. Resolvers, all they do is say, how do you retrieve this data? You've given me this type. I know what this type is. All right, now how do I get it? So in this case, for the post, we're just going to do something simple and say post.all, right? You probably wouldn't want to do that in production code, but you just define how to get the data. The way I think about it is the resolvers are very similar to controllers, right, where they accept input from the user, and it is the resolver's job to turn that input into a command or a query for the application. That's its job, and that's all it really has to do. And here's another example. This one is more like something that you might see in a production GraphQL API. So this one is type tweets, and you can pass in a queue for a query string and a language, which defaults to English. And then what it does is the resolve searches the Twitter API with whatever you pass in, and it does it concurrently in a promise, so it doesn't block the rest of your application. This allows you to do multiple things at once, which is really important in GraphQL, and I'll go over that a bit later. And then finally, we have mutations. So mutations are all about how do we mutate, how do we change or update or create data within our API. Queries, the stuff that I was showing before, they are meant to be idempotent, much like a GET request in HTTP. They don't change anything, right? Like you execute the same thing twice and it's going to return the same result. Mutations change things. So an example of this would be create post. Say we have this query on the left, create post. We want to create it with a title and a body. GraphQL is QL. And then we select what we want the API to return. So mutation, very similar to a query, except it kind of has this expectation that you will create or update things within that mutation. So in this case, we're just creating a post and returning it. Very straightforward. I mean, you can start to see the connection with the controller here, right? These resolvers do usually very simple, straightforward things. They can also be more complex, but they take some input and then they execute some action. In traditional REST terms, this might, you might do put a post request to the, users/post endpoint and have a similar thing. So if you wanted to do like a comment on a post, you could say comment on post with the post ID, and then specify the arguments that you take. We're going to take a post ID and a body, and then we're going to create that comment. Really straightforward. And one little note on the naming conventions here. It's generally a good pattern to give meaning to your mutation names. So instead of saying like update post and passing in some comments, right, we can give it an explicit name, like just comment on this post. I think that's become a powerful pattern because when you're developing a front end or you're interacting with the API, you can look at the code and know exactly what it's doing. As opposed to sometimes when you're using a REST API, you might do a put request of some sort which updates some field, and depending on which fields you pass in, it does something slightly different. So it's a good pattern to make things very explicit in what you're doing and readable. Subscriptions are another feature of GraphQL. So you can think of a subscription as receiving updates to data in real time, right? So if someone comments on a post, you might get a little notification in your top right corner, right? Subscriptions are generic in a sense. They aren't necessarily tied to WebSockets or any specific protocol. All it's saying is that, hey, I am interested in an event of this type, and when this event of this type happens, I want this data, right? So in this case, when a post was published, send me the title and the author name. That's all I need. And the powerful thing about this, I think, is that it really abstracts the protocol that it's working on, right? A lot of people there's a lot of hype around WebSockets and certain implementations of things, but this format is compatible with whatever it is that you want to use. One day that might be HTTP2. So sort of in summary, when to use GraphQL. As with any piece of technology, you don't want to just adopt something because it's like the new hotness, right? Or it looks interesting, right? You need to have good use cases to justify doing it because there is added complexity to your app. So, for example, onboarding new engineers to your code base, it might be harder to teach them some of these things. It might take longer to onboard them. And also, it might not offer all the benefits if your application only does certain things. So when to use GraphQL? Some good use cases would be when you have many different consumers of your API. So say you have a couple of mobile apps and a web dashboard or something else, that might be a good use case. If your product has complex UI, UX needs, so say you have a dashboard of sorts where the user is making lots of updates in real time and you want it to be interactive and fast, GraphQL can be a good solution to having a single page app which allows you to do that. So anything that is a spa with some dynamic or live data. And building a public API, if you're exposing an API to the world, I think consumers in the long term will enjoy it if they didn't have to make 20 requests to get one thing that they need. So that could be a good use case. What probably isn't a good use case is doing it for like very simple CRUD apps or something that isn't very complex, maybe like an admin dashboard or something where it's very straightforward and you can just follow a conventional approach to get it done quickly, right? You don't want to bring in the complexity of something like GraphQL if you're needs are very straightforward. So for that, like, you might just want to stick with the traditional, Rails view stack for that. So GraphQL at ad hoc, I'll talk about some of the things that we have done with it. One thing we're working on now is simplifying campaign creation. So we're building out this whole sort of wizard, which makes the process very simple. We're using GraphQL for that. And one of the cool features that we're using from GraphQL is you can actually, like, unlike REST, where if you're making a post request, oftentimes you have to, it'll be on one resource. So if there are multiple resources that need to be created, you can't do that in one transaction, right? Because you make one request, it sends it back, you make another one, and you kind of have this back and forth communication. One thing we're using GraphQL for here is when creating a campaign, you do create a lot of resources, right? You create campaigns, you create budgets, you create ad groups and ads, right? And we want the user to have this feel like one uniform experience, not like they're, not like it's happening as they're going, but they click save and it works and it's all done. So we're using the GraphQL Mutation to basically wrap that whole thing inside of a transaction so we can create these resources and do it in a way that if something fails, then it'll just go back and fix the whole thing. Not everything will fail. Well, if one thing fails, then the whole thing will revert, rather than being in this sort of middle ground where, hey, we've created a campaign in an ad group, but we couldn't create the budget because something went wrong, right? So then you're stuck with like this sort of half filled out thing. So that's one thing we're using it for. The other thing that we're using it for is Universal Insights API. So if you guys have ever done anything with digital advertising before, there are a bunch of providers for digital advertising these days. There's AdWords, there's Facebook, there's Bing, right? There's Instagram, and they all, at the end of the day, like these reporting APIs all do the same thing, right? They return back some metrics that you care about. A lot of times it'll be like cost, clicks, cost per conversion, whatever it may be, but all the APIs are vastly different. For example, the AdWords API is a SOAP API, and I don't know if you guys have ever dealt with SOAP. I hope you don't have to, but it can be painful. There are a lot of benefits, but I think the usability can be tough sometimes. But what we built was an API which basically sits in front of these APIs, and you specify requests in one syntax, one format like that, and it'll work with any of the providers. So it'll work with Facebook, it'll work with Google, right? And we use GraphQL to sort of deal with all that complexity to make it a painless experience when trying to fish out these important metrics. So I'll go through some of my opinions here on best practices in GraphQL. So the first one, and this is pretty much any API you're building, doesn't have to be GraphQL. Anytime that you're making external API requests, and especially if you're making multiple requests, do it asynchronously. Ruby doesn't really support this very well out of the box. It's sad, but it's not something that's easy to do. By default, any request you make in Ruby is just going to block the entire thread, and you can't do things in parallel. So use promises. They're very similar to JavaScript promises, a little different. They run on threads, not an event loop, but for all intents and purposes, they're mostly the same thing, and it'll allow you to run requests in parallel so things work quickly. And this is ultra important in GraphQL because, as mentioned earlier, you can actually select from as many resources as you want in GraphQL. So I could have one query that's pulling, posts as well as tweets, as well as, Facebook status updates. The list goes on, right? So if you don't make these requests concurrent, then those times can just build up very quickly, and it makes your API slow and not a pleasant experience for both the users and any developer trying to use it. So use relay mutation for mutations. Facebook kind of came up with a conventional format for updating data, right? So if you're, say you're updating a post you want to change the body, or you want to edit it in some way, you would use this relay mutation, which basically is a conventional format for these updates. So that way you can sort of keep track of exactly what was updated. So you don't have to wait back on the server to update it to the UI, for example. So you can do things like optimistic updates. So a user edits something, right, and it looks like it's instant to them, but really it takes however many milliseconds to go back to the server, but it looks instant, and it just feels great for anyone using your application. So use relay connections for lists and collections of data. So a connection is basically you get pagination out of the box, right? One of the golden rules of building an API is make sure you paginate. You can't really offer any sort of API unless you paginate it, because at some point you have to cut off how much you're going to send to a single person, or else it's going to just make everyone else's requests go ridiculously slow. Luckily, this is all built in to GraphQL Ruby and all the other implementations as well. So you just use this connection, and it'll deal with all the pagination for you. And you just pass certain parameters to make the pagination work, and you're good to go. And then I would say name mutations action first and describe what it does. So for example, use upvote comment instead of comment update. This is mostly taste, but I kind of like this style. It sort of displays the intention and then the resource last. So I want to take time for some questions, and here's some resources that I have for you guys to look up on your own. GraphQL Ruby, I talked about. Apollo Data is a JS framework and also works with Swift and other things for sort of managing your data on the client. And then GraphQL.org is just general information about GraphQL. Yeah, so any questions from anyone? This guy.
Okay. So in Ruby on Rails REST context, we teach developers, we as a community as a whole, to use Divide or something like that, and can to do authentication and access control.
Mm-hmm.
One of my concerns with GraphQL is when you have single endpoints crossing down the data model, what is the prescribed way of controlling that so that users can't go through one endpoint to circumvent access controls that are placed at another?
Absolutely, that's a really good question, and very important. So out of the box, GraphQL Ruby, if you just have the community edition, they don't give you that out of the box. They do have a pro version, which they give you this authorization, right? I think they support Pundit and can from it. But what we did is you can actually extend the DSL for GraphQL Ruby. And so what we did is we basically added this little method called authorize. And we say for every single, and we enforce this. So every single type that we have to include authorization on it. So we say authorize, whatever it is, authorize user can create, right? And then we can pass in whatever other policy scopes or whatever else we need. So we basically built something which adds that functionality into GraphQL Ruby. And shortly afterwards, naturally, someone released a gem which did the same thing. So we probably could have used that if we waited. But either way, it's not baked into it, but it's fairly easy to get up and going. So yeah, good question.
That's leveraging your device users and can rules and all that stuff?
Yeah, so we have sort of this Frankenstein-y thing right now where we have a lot of REST endpoints and mix that with our GraphQL and just a hodgepodge of things going on. And we already had all these policies for Pundit, right? And they were already validated and used in production, right? So we were just able to reuse those policies and apply it to our GraphQL. And then one thing I will say is it's much easier to transition over to something like GraphQL if you've taken the time to build out those policies and if you've taken the time to not just shove everything in your controllers and actually like extract them into different services or operations, right? Since we had done that early on, it was fairly easy to just plug it in to GraphQL because it essentially worked as a controller. So it wasn't too messy to do. But yeah, we were able to reuse a lot.
So by default, it doesn't have that.
Have
So I'm going to say, so by default, it doesn't do that. So GraphQL implementations would be a target-rich environment, probably.
Well, you could also say that by default Rails doesn't do it, right? Yeah, every piece of technology is target risk, and I think that, yeah, you really have to pay attention to it. So.
Ian, tell us what ad hoc does. It sounds like you're like a platform to buy ads across multiple sites like Facebook, YouTube, whatever.
So what we do is, our goal is to simplify digital advertising for customers, right? A lot of times our customers are small businesses that want to use digital advertising but can't afford to hire someone full-time to manage whether it's Facebook, Google, or other things, right? So we have this one platform where you can come to, you can get insights on all of your accounts, right? And then we give you tips in real time that are human readable that say, hey, you should increase your bid adjustment in Kansas or whatever it may be, right? We analyze your accounts and give you tips in real time. And we also offer the ability to create campaigns across multiple platforms in one place. So it basically just simplifies the complex world of digital advertising for someone who, say you're one guy at a small business and you need to run ads for your company, you could do it here. Or if you're a larger company, you wouldn't have to, you could use us and you could avoid hiring an ad agency to manage all your ads, right? We can play that role as well.
Do you have much experience or thoughts about using GraphQL with native frameworks?
I don't personally have experience, so I can't speak too much. I do know that there is, within Apollo, they do like support Swift and Android as like a first-class thing. Like I said, I've never actually gone hands-on with it, so I wouldn't know. But at the same time, with GraphQL, you can essentially use it like you would use any other REST API if you wanted to, right? You can just post your query, and it comes back as JSON. So if you can use a REST API, you could use GraphQL. How much of the work that is already done for you depends on what Apollo has done in that, but it's totally possible, and I think it's getting better and better. So.
So we have, I guess, the resolver.
Mm-hmm.
It takes 3 arguments. So if you have a post, which maps comments, which maps the comment on it and the name.
Mm-hmm.
And the first option is does that resolve the post first? And then so you're doing a database lookup there, and then that post is passed down to the comments connection.
Yeah, exactly. So let me see if I can find this. Maybe it was here. I don't know. Okay, so that's not a good example. Where is it? Yeah, so maybe we could, I'll try to explain it from here. But yes, so essentially this, in your resolve functions, you get obj, args, CTX. I mean, these names are just like conventional. We end up renaming that a lot. But so if this was nested, if this query was nested inside of, say, a user's object, your OBJ would be the user right here. So you basically get the context of what's above you. So this helps with doing things that are relational. So we allow to sort of be able to pass down and deal with relational data that way. And then args are just whatever arguments you have, and then context is like everything. Just throw it in there. I don't know.
So when you get all the comment, do you find yourself doing query optimization based on what fields have been requested, like selecting those in the database? Don't do that?
Yeah, absolutely. so we look at our performance and we say, if there is something that it's slow for some reason, right, we'll go in and optimize it. We actually have like a default resolver that we use, which will take your arguments and then only select those fields from the database by default. So if you're, say, like you're getting a post and you only care about the body, there's no reason to select the ID or the title or, you know, created at or updated at, whatever it may be. We just make it so it just pulls out the body, which makes your database performance much faster. But for a lot of stuff, like if it's not heavily used, we don't bother with optimizing it, but it's totally possible.
In your setup, you mentioned one of the limitations of a REST API being that you don't really know what the client is going to use from the return. Are you saying is there built-in analytics with this, or is it just by the nature of the request you gain more insight into what it is they're looking for, or is it some mix of that?
Yeah. What I sort of meant by that was, like in the REST model, you would get insights into like how often people are using this endpoint, right? I know when they made a request to this endpoint, and I can sort of know what parameters they sent me, but I don't know what their intention was necessarily. I just know that they wanted to use this endpoint. So with GraphQL, there are libraries which will analyze your GraphQL server and actually like take metrics as to, hey, what types were used, what fields were selected on these types. So it'll go through and give you like, hey, you know, this body field is requested 99% of the time, or whatever it is. There's this library optics which does that. But I guess sort of the point was somewhat theoretical in the sense that like you're able to sort of really understand the intentions of your users that are using your API. So you could say, hey, I know that this guy was requesting this endpoint, and he only wanted the repository ID and the first comment. So we know what he was actually looking for there. So that's very important. Anyone else? Awesome. Well, thanks for having me.
This video has been sponsored by Rieta Incorporated. Learn more today at RIE.